Hi everyone, I'm R. Samundishwari, Assistant Professor in Civil Engineering, working at University College of Engineering, Tirukkuvalai. Now I'm going to teach about the permeability concept in soil mechanics. We'll see the introduction to the permeability. In soil mechanics and foundation engineering, you must know how much water is flowing through a soil in unit time. Actually, this knowledge is required to design earthen dams, to determine the quantity of seepage under hydraulic structures, and dewatering process done before and during foundation construction. Actually, what is meant by permeability? A permeability of a soil is defined as a capacity of soil to allow water passes through it. It can also be briefly defined. It is an engineering property of soil in which soil mass allows the water to flow through it. Look into this figure, which shows the comparison of permeability value through various type of soil. Consider for a 1 meter height of soil medium in which the water can pass through it. See, in the first figure, gravel, in the gravel, actually the water takes 2 minutes to flow through the distance of 1 meter. As gravel is highly pervious, so that the water can flow through easily it. As a clay is impervious, water cannot easily flow through it. Sometimes it takes 200 years to cross a distance of 1 meter height. Similarly, we can say that rocks are impermeable. See the permeability values which has been given in the table. Soil type, permeability in centimeters per second. Gravel is 1 to 100 centimeters per second. Compare this with clay, it is less than 10 power minus 6 centimeters per second. Then we will discuss about the factors affecting the permeability of soil. There are more or less 10 factors which affects the permeability of soils, which finds more important in designing the foundation. Number 1 is particle size. Number 2, void ratio of soil. Number 3, properties of pore fluid. Number 4, shape of particles. Number 5, structure of soil mass. Number 6, degree of saturation. Number 7, adsorbed water. Number 8, entrapped air and organic impurities in water. Then finally, temperature and stratification of soil. Then we will discuss about the Darcy's law, which finds is more important in determining the permeability values. Darcy's law states that in laminar flow conditions, water flowing through the porous media is directly proportional to head loss and indirectly proportional to the length of flow path. This may also be expressed as small v is equal to k into I. V is equal to k, where the I is the hydraulic gradient, where it can be expressed as del H by L. In this equation, K is the permeability coefficient and V is the discharge velocity. Coming to what is meant by discharge velocity, It is defined as the velocity of water flow through the soil mass takes place through cross-sectional area of soil mass which is perpendicular to the direction of flow. Then V is equal to Q by A. Seepage velocity. Seepage velocity of water is defined as where the flow takes place through the area of voids. Look into this figure where this is the total mass of total area of soil specimen. Look into the second figure where the first part of the semicircle consists of area of voids and the second one is area of solids. That is the the relationship can be established between the discharge velocity and the seepage velocity, where Q equals A into V, or it can also be written as area of voids into seepage velocity, where capital A is area of the soil mass and small b is the discharge velocity. So, these two can be related. A sub A into B is equal to A suffix V into V suffix S. It can also be expressed as V is equal to N into Vs, where N is the porosity, where it can be defined as the ratio between the area of voids to area of soil mass. I hope you would be understand the basic concepts of permeability. Thank you.